Hello all, welcome back to my channel. So in today's video, I'll be sharing with you AWS Solution Architect Associate Practice Exam Questions Part 2. So in this particular series, I'm making the exam questions which you can practice before going for the Solution Architect Associate exam. If you are new to the channel, make sure you hit that subscribe button so you don't miss any of my future videos. So without any further ado, let's get started. Question number 11. So I have created a series. I will leave the link in the description box for part 1. You can go and check out the part 1 of this particular series. So question number 11, it says a company has an application that runs on Amazon EC2 instances and uses an Amazon Aurora database. The EC2 instances connect to the database by using usernames and passwords that are stored locally in a file. The company wants to minimize the operational overhead of credential management, which should what should a solution architect do to accomplish this particular goal? So basically, as a company who have saved the username and password locally in a file, which I wouldn't suggest. That's not a safe practice to do. Then the company wants to minimize the operational overhead of the credential management. So in order to accomplish this particular goal, what a solution architect should propose. So your options are: A, use AWS Secrets Manager, turn on automatic rotation. Option B, use AWS Systems Manager Parameter Store, turn on automatic rotation. Option C, create an Amazon S3 bucket to store objects that are encrypted with an AWS key management service encryption key. Migrate the credential file to the S3 bucket. Point the application to the S3 bucket. Option D, create an encrypted Amazon Elastic block store volume for each EC2 instance. Attach the new EBS volume to each EC2 instance. Migrate the credential file to the new EBS volume. Point the application to the new EBS volume. Now let's see what is the correct option. And the correct option is A, use AWS Secrets Manager, turn on automatic rotation. So that is how this particular task can be accomplished. Now let's look into question number 12. A global company hosts its web application on Amazon EC2 instances behind an application load balancer. The web application has static data and dynamic data. The company stores its static data in Amazon S3 bucket. The company wants to improve performance and reduce latency for the static data and dynamic data. The company is using its own domain name registered with Amazon Route 53. What should a solutions architect do to meet these requirements? So basically, company wants to improve the performance and reduce latency for the static data and dynamic data. And static data they are storing on S3 bucket. So this is what they have given. They have hosted a web application on Amazon EC2 instance behind an ALB, and they have two types of data in this web application, which is static data and dynamic data. And static data is stored on S3 bucket. And now they are looking to improve the performance and reduce the latency for the static and dynamic data. Now what they want is solution architect should design some these requirements. In order to meet these requirements, design a solution. Now let's look into the options. Option 8 says create an Amazon CloudFront distribution that has the S3 bucket and the ALB as origins. Configure Route 53 to route traffic to the CloudFront distribution. Option B, it says create an Amazon CloudFront distribution that has the ALB as an origin. Create an AWS global accelerator standard accelerator that has the S3 bucket as an endpoint. Configure Route 53 to route traffic to the CloudFront distribution. Then option C, it says create an Amazon CloudFront distribution that has the S3 bucket as an origin. Create an AWS global accelerator standard accelerator that has the ALB and the CloudFront distribution as endpoints. Create a custom domain name that points to the accelerator DNS name. Use the custom domain name as an endpoint for the web application. Then option D, it says create an Amazon CloudFront distribution that has the ALB as an origin. Create an AWS Global Accelerator, a standard accelerator that has S3 bucket as an endpoint. Create two domain names. Point one domain name to the CloudFront DNS name for dynamic content. Point the other domain name to the accelerator DNS name for static content. Use the domain names as endpoints for the web application. Now let's look into the correct option. And the correct option is A, which says create an Amazon CloudFront distribution that has the S3 bucket and the ALB as origins. So basically, create a CloudFront distribution which has S3 bucket and ALB as the origins, and then configure Route 53 to route traffic to the CloudFront distribution. So that is a solution which is provided by Solution Architect to meet these requirements. Now let's look into the next question. Question number 13. A company performs monthly maintenance on its AWS infrastructure. During these maintenance activities, the company needs to rotate the credentials for its Amazon RDS for MySQL databases across multiple AWS regions. Which solution will meet these requirements with the least operational overhead? So basically, the options are: A, store the credentials as secret in AWS Secrets Manager, use multi region secret replication for the required regions, configure Secrets Manager to rotate the secrets on a schedule. Then option B is store the credentials as secret in AWS Systems Manager by creating a secure string parameter, use multi-region secret replication to the required regions, configure Systems Manager to rotate the secrets on a schedule. Then option C, it says store the credentials in an Amazon S3 bucket that has a server-side encryption enabled. Use Amazon Event Bridge, Amazon CloudWatch events to invoke an Amazon Lambda function to rotate the credentials. Then option D, it says encrypt the credentials as secrets by using AWS Key Management System multi-region customer managed keys. Store the secrets in an Amazon DynamoDB global table. Use an Amazon Lambda function to retrieve the secrets from DynamoDB. Use the RDS API to rotate the secrets. Now let's look into the correct option. And the correct option is A, which says store the credentials as secrets in AWS Secret Manager. Use multi-region secret replication for the required regions. Configure Secrets Manager to rotate the secrets on a schedule. So, guys, let's see the next question. Question number 14. A company runs an e commerce application on Amazon EC2 instances behind an application load balancer. The instances run in an Amazon EC2 auto scaling group across multiple availability zones. The auto scaling groups scales based on CPU utilization matrix. The e commerce application stores the transaction data in a MySQL 8 database that is hosted on a large EC2 instance. The database's performance degrades quickly as application load increases. The application handles more read requests than write transactions. The company wants a solution that will automatically scale the database to meet the demand of unpredictable read workloads while maintaining high availability. Which solution will meet these requirements? So the options are: A, use Amazon Redshift with a single node for leader and compute functionality. B, use Amazon RDS with a single AZ deployment. Configure Amazon RDS to add reader instances in a different availability zone. Option C, use Amazon Aurora with multi AZ deployment. Configure Aurora autoscaling with Aurora replicas. Option D, use Amazon Elastic Cache for Memcache with EC2 spot instances. Now let's look into what is the solution for this particular requirement. And the correct answer is C, that is use Amazon Aurora with a multi AZ deployment. Configure Aurora autoscaling with Aurora replicas. So if the company will perform and use this particular solution, so in that case, whenever the application load increases, database's performance will not degrade, and it will help in maintaining the high availability in the case of unpredictable read workloads. Now let's look into the next question. Question number 15. A company recently migrated to AWS and wants to implement a solution to protect the traffic that flows in and out of the production VPC. The company has had an inspection server in its own on premises data center. The inspection server performs specific operations such as traffic flow inspection and traffic filtering. The company wants to have the same functionalities in the AWS Cloud. Which solution will meet these requirements? And the options are: A, use Amazon Guard Duty for traffic inspection and traffic filtering in the production VPC. Use traffic mirroring to mirror traffic from the production VPC for traffic inspection and filtering. Use AWS Network Firewall to create the required rules for traffic inspection and traffic filtering for the production VPC. Use AWS Firewall Manager to create the required rules for traffic inspection and traffic filtering for the production VPC. Now let's look into the correct option. And the correct option is C, that the company should use AWS Network Firewall to create the required rules for traffic inspection and traffic filtering for the production VPC. Now let's look into the next question. Question number 16. A company hosts a data lake on AWS. The data lake consists of data in Amazon S3 and Amazon RDS for PostgreSQL. The company needs a reporting solution that provides data visualization and includes all the data sources within the data lake. Only the company's management team should have full access to all the visualizations. The rest of the company should only have limited access. Which solution will meet these requirements? So these are the options that are given to us. Option A, it says create an analysis in Amazon QuickSight, connect all the data sources and create new data sets, publish dashboards to visualize the data, share the dashboards with the appropriate IAM roles. Option B, it says create an analysis in Amazon QuickSight, connect all the data sources and create new data sets. Publish dashboards to visualize the data. Share the dashboards with appropriate users and groups. And option C, it says create an AWS glue table and crawler for the data in Amazon S3. Create an AWS glue extract, transform and load ETL job to produce reports. Publish the reports to Amazon S3. Use S3 bucket policies to limit access to the reports. Now let's look into option D. Create an AWS glue table and crawler for the data in Amazon S3. Use Amazon Athena federated query to access data within Amazon RDS for PostgreSQL. Generate reports by using Amazon Athena. Publish the reports to Amazon S3. Use S3 bucket policies to limit access to the reports. Now let's look into the correct option. And the correct option is B. Create an analysis in Amazon QuickSight. Connect all the data sources and create new data sets. Publish dashboards to visualize the data. Share the dashboards with the appropriate users and groups. Let's look into the next question now, question number 17. And it says a company is implementing a new business application. The application runs on two Amazon EC2 instances and uses an Amazon S3 bucket for document storage. A solutions architect need to ensure that the EC2 instances can access the S3 bucket. What should the solution architect do to meet this requirement? So basically there are two Amazon EC2 instances which uses an Amazon S3 bucket for document storage, and solution architect needs to ensure that EC2 instances can access the S3 bucket. So the options are: option A, create an IAM role that grants access to the S3 bucket, attach the role to the EC2 instances. Option B, create an IAM policy that grants access to S3 bucket, attach the policy to EC2 instances. Option C, create an IAM group that grants access to the S3 bucket, attach the group to the EC2 instances. And option D, create an IAM user that grants access to the S3 bucket, attach the user account to the EC2 instances. Now let's see what is the correct option for it. And the correct option is A, create an IAM role that grants access to the S3 bucket, attach the role to the EC2 instances. Now let's look into the next question, question number 18. An application development team is designing a microservice that will convert large images to smaller compressed images. When a user uploads an image through the web interface, the microservice should store the image in an Amazon S3 bucket, process and compress the image with an Amazon Lambda function, and store the image in its compressed form in a different S3 bucket. A solution architect needs to design a solution that uses durable, stateless components to process the images automatically. Which combination of actions will meet these requirements? And you have to choose two options over here. And the options are A, create an Amazon simple queue service queue. Configure the S3 bucket to send a notification to the S3 SQS queue when an image is uploaded to the S3 bucket. Option B, configure the Lambda function to use the SQS queue as the invocation source. When the SQS message is successfully processed, delete the message in the queue. And option C is configure the Lambda function to monitor the S3 bucket for new uploads. When an uploaded image is detected, write the file name to a text file in memory and use the text file to keep track of the images that were processed. Option D is launch an Amazon EC2 instance to monitor an SQS queue. When items are added to the queue, log the file name in the text file on the EC2 instance and invoke the Lambda function. Option E, it says configure an Amazon event bridge, Amazon CloudWatch event to monitor the S3 bucket. When an image is uploaded, send an alert to an Amazon Ample notification SNS topic with the application owner's email address for further processing. And the correct options are A and B. that is create an SQS queue, configure the S3 bucket to send a notification to the S3 SQS queue when an image is uploaded to the S3 bucket. And option B is configure the Lambda function to use SQS queue as the invocation source. When the SQS queue is successfully processed, delete the message in the queue. Okay, guys, so if you are liking this video, give it a thumbs up and subscribe to my channel so that I can keep creating such more informative videos. So, without any further ado, let's go to the next question, question number 19. And it says a company has a three-tier web application that is deployed on AWS. The web servers are deployed in a public subnet in a VPC. The application servers and database servers are deployed in private subnet in the same VPC. The company has deployed a third party virtual firewall application from AWS Marketplace in an inspection VPC. The appliance is configured with an IP interface that can accept IP packets. A solution architect needs to integrate the web application with the appliance to inspect all traffic to the application before the traffic reaches the web server. Which solution will meet these requirements with the least operational overhead? And the options are: A. Create a network load balancer in the public subnet of the applicant's VPC to route the traffic to the appliance for packet inspection. Option B. Create an application load balancer in the public subnet of the application's VPC to route the traffic to the appliance for packet inspection. Option C. Deploy a transit gateway in the inspection VPC. Configure route tables to route the incoming packets through the transit gateway. Option D is deploy a gateway load balancer in the inspection VPC. Create a gateway load balancer endpoint to receive the incoming packets and forward the packet to the appliance. Let's look at the correct option. And the correct option is D, that is deploy a gateway load balancer in the inspection VPC. Create a gateway load balancer endpoint to receive the incoming packets and forward the packets to the appliance. Now let's look into the next question. Question number 20. A company wants to improve its ability to clone large amount of production data into a test environment in the same AWS region. The data is stored in Amazon EC2 instances on Amazon Elastic Block Store volumes. Modification to the cloned data must not affect the production environment. The software that accesses this data requires consistently high IO performance, input output performance. A solution architect needs to minimize the time that is required to clone the production data into the test environment. Which solution will meet these requirements? And the options are: A. Take EBS snapshots to the production EBS volumes, restore the snapshots onto the EC2 instance store volumes in the test environment. Option B. Configure the production EBS volumes to use the EBS multi-attach feature. Take EBS snapshots of the production EBS volumes. Attach the production EBS volumes to the EC2 instances in the test environment. Option C. Take EBS snapshots of the production EBS volumes. Create and initialize new EBS volumes. Attach the new EBS volumes to EC2 instances in the test environment before restoring the volumes from the production EBS snapshots. Then option D is take EBS snapshots of the production EBS volumes. Turn on the EBS fast snapshot restore feature on the EBS snapshots. Restore the snapshots into the new EBS volumes. Attach the new EBS volumes to EC2 instances in the test environment. The correct option is option D, which says you have to take the EBS snapshots of the production EBS volumes and turn on the EBS fast snapshot restore feature on the EBS snapshots. Restore the snapshots into the new EBS volumes and attach the new EBS volumes to EC2 instances in the test environment. So that is what you are supposed to do. Now let's look into question number 21. An e-commerce company wants to launch a one deal a day website on AWS. Each day will feature exactly one product on sale for a period of 24 hours. The company wants to be able to handle millions of requests each hour with millisecond latency during peak hours. Which solution will meet these requirements with the least operational overhead? And the options that are given to us are: A. Use Amazon S3 to host the full website in different S3 buckets. Add Amazon CloudFront distributions. Set the S3 buckets as origin for the distribution. Store the order data in Amazon S3. And option B is deploy the full website on Amazon EC2 instances that run in auto scaling groups across multiple availability zones. Add an application load balancer to distribute the website traffic. Add another ALB for the backend APIs. Store the data in Amazon RDS for MySQL. Then option C is migrate the full application to run in containers. Host the containers or Amazon Elastic Kubernetes service. Use the Kubernetes cluster autoscaler to increase and decrease the number of pods to process bursts in traffic. Store the data in Amazon RDS for MySQL. Option D is use an Amazon S3 bucket to host the website's static content. Deploy an Amazon CloudFront distribution. Set the S3 bucket as the origin. Use Amazon API Gateway and AWS Lambda functions for the backend APIs. Store the data in Amazon DynamoDB. And the correct option is D. Now let's look into the next question. Question number 22. A solution architect is using Amazon S3 to design the storage architecture for new digital media application. The media files must be resilient to the loss of an availability zone. Some files are accessed frequently while other files are rarely accessed in an unpredictable manner. The solution architect must minimize the cost of storing and retrieving the media files. Which storage option meets these requirements? And the options are A S3 standard, B S3 intelligent tiering, C S3 standard infrequent access, D S3 one zone infrequent access. And the correct option is B S3 intelligent tiering. Now let's look into question number 23. A company is storing backup files by using Amazon S3 standard storage. The files are accessed frequently for 1 month. However, the files are not accessed after 1 month. The company must keep the files indefinitely. Which storage solution will meet these requirements most cost effectively? A. Configure S3 intelligent tiering to automatically migrate objects. B. Create an S3 lifecycle configuration to transition objects from S3 standard to S3 Glacier Deep Archive after 1 month. C. Create an S3 lifecycle configuration to transition objects from S3 standard to S3 standard infrequent access after 1 month. D. Create an S3 lifecycle configuration to transition objects from S3 standard to S3 one zone infrequent access after 1 month. And the correct option is B, that is create an S3 lifecycle configuration to transition objects from S3 standard to S3 Deep Glacier archive after 1 month. Now let's look into the next question. Question number 24. A company observes an increase in Amazon EC2 cost in its most recent bill. The billing team notices unwanted vertical scaling of instance types for a couple of EC2 instances. A solutions architect need to create a graph comparing the last 2 months of EC2 costs and perform an in-depth analysis to identify the root cause of the vertical scaling. How should the solution architect generate the information with the least operational overhead? And the options are A. Use AWS budgets to create a budget report and compare EC2 costs based on instance types. B. Use Cost Explorer's granular filtering feature to perform an in depth analysis of EC2 costs based on instance types. C. Use graphs from the AWS billing and cost management dashboard to compare EC2 costs based on instant types for the last 2 months. D. Use AWS cost and usage reports to create a report and send it to an Amazon ES3 bucket. Use Amazon QuickSight with Amazon S3 as a source to generate an interactive graph based on instance types. Now let's look into the correct answer. And the correct answer is B, that the person has to use Cost Explorer's granular filtering feature to perform an in-depth analysis of EC2 cost based on instant types. Now let's look into the next question. Question number 25. A company is designing an application. The application uses an AWS Lambda function to receive important information through an Amazon API gateway and to store the information in an Amazon Aurora PostgreSQL database. So basically, an application uses AWS Lambda function, which receives information through API gateway to store the information in an Amazon Aurora PostgreSQL database. So during the proof of concept stage, the company has to increase the Lambda quota significantly to handle the high volumes of data that the company needs to load into the database. A solutions architect must recommend a new design to improve the scalability and minimize the configuration effort. Which solution will meet these requirements? And the options are A. Refactor the Lambda function code to Apache Tomcat code that runs on Amazon EC2 instances. Connect the database by using native Java database connectivity JDBC drivers. Option B. Change the platform from Aurora to Amazon DynamoDB Provision a DynamoDB accelerator cluster. Use the DAX client SDK to point the existing DynamoDB API calls to the DAX cluster. Option C, set up two Lambda functions. Configure one function to receive the information, configure the other function to load the information into the database. Integrate the Lambda functions by using Amazon SNS. Option D, set up two Lambda functions. Configure one function to receive the information, configure the other function to load the information into the database. Integrate the Lambda functions by using an SQS queue. Now let's look into the correct option. And the correct option is D. Now let's move on to the next question. Question number 26. A company needs to review its AWS Cloud deployment to ensure that its Amazon S3 buckets do not have an unauthorized configuration changes. What should a solutions architect do to accomplish this goal? And the options are A. Turn on AWS config with the appropriate rule. Turn on AWS Trusted Advisor with the appropriate checks. C. Turn on Amazon Inspector with the appropriate assessment template. D. Turn on Amazon S3 Server Access Logging. Configure Amazon Event Bridge, Amazon CloudWatch events. Now let's look into the correct option, and the correct option is A. Turn on AWS config with the appropriate rules. Let's look into question number 27. A company is launching a new application and will display application metrics on an Amazon CloudWatch dashboard. The company's product manager needs to access this dashboard periodically. The product manager does not have an AWS account. A solutions architect must provide access to the product manager by following the principle of least privilege. Which solution will meet these requirements? The options are A. Share the dashboard from the CloudWatch console. Enter the product manager's email address and complete the sharing steps. Provide a shareable link for the dashboard to the product manager. Option B, create an IAM user specifically for the product manager. Attach the CloudWatch read only access AWS managed policy to the user. Share the new login credentials with the product manager. Share the browser URL of the correct dashboard with the product manager. Option C is create an IAM user for the company's employees. Attach the view only access AWS managed policy to the IAM user. Share the new login credentials with the product manager. Ask the product manager to navigate to the CloudWatch console and locate the dashboard by name in the dashboard section. Option D is deploy a Bastion server in the public subnet. When the product manager requires access to the dashboard, start the server and share the RDP credentials. On the Bastion server, ensure that the browser is configured to open the dashboard URL with cached AWS credentials that have appropriate permissions to view the dashboard. And the correct option is A, that share the dashboard from the CloudWatch console, enter the product manager's email address and complete the sharing steps. Provide a shareable link for the dashboard to the product manager. Now let's look into question number 28. A company is migrating applications to AWS. The applications are deployed in different accounts. The company manages the accounts centrally by using AWS organizations. The company's security team needs a single sign on solution across all the company's accounts. The company must continue managing the users and groups in its on premises self managed Microsoft Active Directory. Which solution will meet these requirements? And the options are A. Enable SSO from the AWS SSO console. Create a one-way forest trust or a one-way domain trust to connect the company's self-managed Microsoft Active Directory with AWS SSO by using AWS Directory Service for Microsoft Active Directory. Option B is enable AWS SSO from the AWS SSO console. Create a two-way forest trust to connect the company's self-managed Microsoft Active Directory with AWS SSO by using AWS Directory Service for the Microsoft Active Directory. Option C is use AWS Directory Service. Create a two-way trust relationship with the company's self-managed Microsoft Active Directory. Option D is deploy an identity provider on premises. Enable AWS SSO from the AWS SSO console. And the correct option is B. Now let's look into the next question. That is question number 29. And it says a company provides a voice over internet protocol service that uses UDP connections. The service consists of Amazon EC2 instances that run in an auto scaling group. The company has deployments across multiple AWS regions. The company needs to route users to the region with the lowest latency. The company also needs automated failover between regions. Which solution will meet these requirements? And the options are A. Deploy a network load balancer and an associated target group. Associate the target group with the auto scaling group. Use the NLB as an AWS Global Accelerator endpoint in each region. Option B. Deploy an application load balancer and an associated target group. Associate the target group with the auto scaling group. Use the ALB as an AWS Global Accelerator endpoint in each region. Then option C, deploy a network load balancer and associated target group. Associate the target group with the auto-scaling group. Create an Amazon Route 53 latency record that points to aliases for each NLB. Create an Amazon CloudFront distribution that uses the latency record as an origin. Option D is deploy an application load balancer and an associated target group. Associate the target group with the auto-scaling group. Create an Amazon Route 53 weighted record that points to aliases for each ALB. Deploy an Amazon CloudFront distribution that uses the weighted record as an origin. And the correct option is A, which is deploy an NLB and an associated target group. Associate the target group with the auto scaling group. Use the NLB as an AWS Global Accelerator endpoint in each region. Now let's look into question number 30. A development team runs monthly resource intensive tests on its purpose Amazon RDS for MySQL DB instance with performance insights enabled. The testing lasts for 48 hours once a month and is the only process that uses the database. The team wants to reduce the cost of running the test without reducing the compute and memory attributes of the DB instances. Which solution meets these requirements most cost effectively? Option A is stop the DB instance when tests are completed, restart the DB instance when required. Option B is use an auto scaling policy with the DB instance to automatically scale when tests are completed. Option C, create a snapshot when tests are completed, terminate the DB instance, and restore the snapshot when the required. Option D, modify the DB instance to a low capacity instance when tests are completed. Modify the DB instance again when required. And the correct option is C, that create a snapshot when the tests are completed, terminate the DB instance, and restore the snapshot when required. So that's it for today for this particular video. I hope you enjoyed the video and this video was informative for you. All the best for exam and give this video a thumbs up if you like the video and please subscribe to my channel. Thank you. Bye bye.